Hello everyone again. So I'm making a couple of videos here to show you how you can use the calculator, that is your TI-83, 84, or 89, to compute probabilities of normal distributions without using the table. I'm going to try to avoid using tables in this class, at least for normal distributions, because we have a very nice calculator functions that will take a big burden of it away if you just know how to use them. And there are really only just two commands that we really need to know. It's going to be invert the Normal Cdf command and the inverse norm command. The Normal Cdf command is what you use when you want to compute areas under normal curves. Okay, so in this case we have the standard normal curve where the mean is 0 and the standard deviation is 1. And in that case, this area can be calculated using what we call the Normal Cdf command. And in this case, we just have to input the boundaries of this area. Now in this case, this one goes all the way down to the very end, to technically negative infinity. You may have negative infinity as a boundary on your calculator if it's advanced, but on mine I don't, so I just usually put negative 10,000. Any really big negative number like that will usually work, as long as it's far away from the mean, which is in this case is 0. And then the right endpoint is negative 0.8. Okay, and that's all we need because we're using the standard normal distribution. In some cases, you could also input comma 0 and comma 1 if they're asking for the mean and the standard deviation. So to do this, you on our calculator, you hit second and then the distribution button, and then you see the second one you want is Normal Cdf. You never use Normal PDF, so you always Normal Cdf because it's a cumulative distributive function. And then you just enter in your numbers. In this case, it was negative 1,000, or negative 10,000, or negative infinity, and negative 0.8. Okay, and you enter that, and you see that the answer is 0.2118 or 0.212. Okay, so the area in this case is 0.212. For this next example, you can see what the boundaries are. The left boundary is negative 0.5, and this one, the right boundary is 1.6. So this will be Normal Cdf of negative 0.5 and 1.6. Okay. Again, we don't need to input anything else because this is a standard normal distribution. And this turns out to be 0.637. The next one, here the left boundary is 0.4, the right boundary is positive infinity. So this would be Normal Cdf of 0.4. Positive infinity if you have it, or you can just write positive 10,000. Okay, and so that's what this area is, and this turns out to be 0.345. Now, the other thing we have, the other command you use is when let's say you're given the area and you want to find the boundary. In this case, let's say the area is of this area under the curve is 0.31, and in that case you use the inverse norm function. And in this case, you just you enter the area to the left of the number you're trying to find. It's always the area to the left, which in this point is 0.31. Okay, so that's what z is. And to find that, once again, you go to turn this on, and you go to the distribution button, and you'll see that the inverse norm is right below the Normal Cdf command. Okay, and now you just enter 0.31, and you'll see that's negative 0.495 or negative 0.496 if you round. In this last example, you'll see things are going to be a little bit different because you can't enter 0.60 because you want to find, you want to find both of these numbers. And the way you do that is you want to first find what is the area here. And you know that this area plus this area plus this area equals 1. So this area plus this area must equal 0.4. And these are equal areas, so divide 0.4 by 2. And so this is 0.20. Okay. So minus z is going to be the inverse norm of 0.2 or 0.20, and that turns out to be negative 0.842 when you round up. And then z is going to be positive 0.842. Okay. Now let me remind you, all of these, with all these distributions, this was a standard normal distribution. So mu is 0, sigma equals 1. We're going to see some examples in the next video where you have to enter, you have different means and different standard deviations.